Hello, grade 12 STEM. Welcome for today's discussion. We will be dealing about work and center of mass. So we will be focusing our lesson into these two uh, variables, work and the center of mass. First, let us deal about work. What is work? Work done by this constant force is the product of the force magnitude in the direction of a displacement and the displacement magnitude, meaning work is the product of force and displacement. So take note, this one is the displacement magnitude, or simply in some books we have W is equal to FD, but in this portion we will be using delta X as the displacement. So take note, W is the work and it is measured in unit. We have Newton meter, or simply in joule. So 1 Newton meter is equal to 1 joule. So that is for work. Next, we already know what is force. Force is measured in Newton, or we have kilogram meter per second square. And lastly, this one, delta X, or displacement, this one is measured in meters. Okay, meters is small letter M. So that is all about the variables or the quantities under force. Another one, we also have W is equal to force cosine angle delta X if there is a angle present in the illustration or in the given problem. Take note, guys, that if any of these variables increase, meaning work will also increase, in the sense that W is directly proportional to force and into displacement. So always remember, if F increases, definitely work will also increase. If the displacement increases, definitely again, work will also increase. Okay, so let's have a simple example. So I will just draw an illustration. Okay, so example, we have here a box. We have here a box. Then I pull this box into this direction, exerting a force which is equivalent to 15 Newton. So, I move the box into this portion. Okay? So, this one is the box with a distance or displacement of 5.0 meters. So, therefore, 5.0 meter is the delta X. And as I pull the box, I am forming an angle, which is equivalent to 25 degrees. What will be the work done I exert in moving the box into this initial position into the final position? So, what will be the work done? So, first step, draw the illustration. So, we already have this illustration. Then, next step, we have step 2, determine the given. So, what are the different given in this illustration? So, we have here F, and take note, since I pull the box vertically, so meaning I will use Fx. So, force X, or the applied force, is equivalent to 15.0 Newton. Next, we have also here the angle, which is equivalent to 25 degrees. And again, the change in position, or delta X, we have 5.0 meter. So we already have the given. The next is our unknown. We have here W, or the work done, unknown siya. Then for our formula, we already know what formula are we going to use. this one. Okay, so we have W is equal to F cosine theta multiplied by delta X. So that's it. Next is for the solution. So for our solution, we have W F cosine theta delta X. Just substitute the values. So F is 15.0 Newton multiplied by this one, cosine 25 degrees times 5.0 meter. Next, in solving this problem, first you need to determine the value of cosine 25 degrees. Take note, just use 2 decimal places. So we have this portion, we have cosine 25 equals, so 0.906. So this will be 0.91. So let's write 15.0 Newton times 0.91 times 5.0 meters. So ready to solve. So we have 15 times 0.91 times 5.0. So the answer will be 68.25. So W is 68.25. Remember the units, Newton meter, or simply 68.25 joules. So this will be our answer in that certain illustration. So get it, guys? Okay, so very good. This is along the x-axis. Okay, vertical siya. Next, let's have another example under the y-axis. So, for example, let's have here a truck. Example number 2. So, for example, we have here a truck. I will put the truck into this position, into the alley. So, for example, pupunta yung truck sa boat. So, this will be pulled by a string in order to put the truck into this position. So, we have here the initial position, then this one is the final position. Okay? So, going upward siya. Because you carried it up to put it into this area, into a boat. Okay? So, that will be the illustration. What will be the given? So, step 2, we have here the given. I will just write the given. For example, the mass of the truck is 4,000 kilogram. I use a force which is 50 kilonewton to carry the truck into this area. Then we have here the distance is 4.0 meter as you carried it upward. So the distance is delta y, the distance is 4.0 meter. Then since it goes upward, do not forget to write the gravity. Okay, 9.8 meter per second square. But in this portion, instead of using meter per second square, this should be negative 9.8 meter per second square. Instead of using negative 9.8 meter per second square, let's just use negative 9.8 Newton per kilogram, since we are talking about work. Okay, so question, why is it meter per second square naging Newton kilogram? That is because meter per second square and Newton kilogram are same. How? So take note of this illustration. So note, we have here Newton kilogram is equivalent to meter per second square. Paano nangyari? So, we have Newton over kilogram is equal to, ano ba yung equivalent ng Newton? We have kilogram meter per second square divided by kilogram. So, we have cancel kilogram and kilogram. So, yung natira lang guys is we have Newton kilogram is equal to meter per second square. So, see, both of them are equal. So, let's just use negative 9.8 Newton per kilogram as the unit for, or as the value for gravity. Okay, so let's proceed. Unknown for in this illustration, we have here our unknown. So let's assume you need to find the work done. Next, you also need to find the work done due to gravity and what will be the net force. Pag sinabi nating net force will be the total net force. The total net or net work. So we have B and C. First is let's solve for the work done. So letter A, W, our formula, we have W is equal to Fy delta Y. Okay, so bakit walang angle? That is because it is just pulled upward. Walang angle na nabuo. Okay, so solution. So just substitute the values. Fy, we have that one, 50 kilonewton multiplied by delta Y is 4.0 meter. So this will be 50 times 40. This will be 200 kilonewton meter or 200 kilojoule. So this will be the answer in letter A. Work done. Next we have work done due to gravity. So, formula naman natin dito, work done due to gravity, we will have Wg is equal to mgy delta y. So, we have here your mass, gravity, then your displacement along y-axis. So, just substitute the given value. So, we have here solution. So, we have Wg is equal to, mass is equivalent to yan, 4,000 kilogram. 4,000 kilogram multiplied by negative 9.8 Newton per kilogram. Multiplied by, we have your delta y is 4.0 meter. 4.0 meter. So, Wg is equivalent to, let's have 4,000 times negative 9.8 times 4 equals, so negative 156,800. So, the unit will be cancel kilogram and kilogram. This will be Newton meter. So, we have negative 156,800 Newton meter or negative 156,800 joule. Okay, so we have negative 156,800 joules. We should make this one the same to the unit into the first solution, which is the work done. We should make joules into kilojoules. So, take note, 1 kilo is equivalent to 1,000. Meaning, negative 156,800 joules must be divided into 1,000. So, negative 156,800 joules divided by 1,000 is equivalent to negative 156.8 kilojoules. So, our Wg will be negative 156.8 kilojoules. So, that will be the Wg. Next is to find for the work done. net or the net work. So, the formula that we are going to use in this illustration is, since this one is work net, you need to add the total, or you need to find the total work done. So, you need to add W plus WG. And take note, W is equal to 200 kilojoule and WG is equivalent to 156.8 kilojoule. So, we have 200 kilojoule plus negative 156.8 kilojoule. So, this will be equivalent to, we have 200 minus 156.8. So, this will be equivalent to 43.2 kilojoules. So, this will be the net work. Okay? So, that is how to solve the work done into two different examples. Okay, so next is the center of mass, or so the center of mass of a body or a system of bodies is that moves as though all the mass were concentrated there and all external forces were applied there. So all mass are concentrated. So for example, this one is you. In what position does your center of mass located? So definitely, this is the position where all of your mass is concentrated. So it should be present in your abdomen. So abdomen, not in your feet, not so it is present in your abdomen. So next, when we say center of mass, it is the point of an object at which all the mass of the object is thought to be concentrated. This point is called the center of mass of the system. Note that it is the balancing point for the mass distribution. So meaning this is where your equilibrium is located. It balances your mass. So for example, we have here different shapes and it's different center of mass. So this one is a full circle, so it is located at the center. So this color red is the center of mass. Next is this one. For example, this one is a ring. It is located in this position. So we also have here a rectangle. Again, it is located at the center. Then lastly, we have here a triangle. Ito naman siya. So this is the center of mass. But in this certain part, we have different formulas in finding the center of mass of the different objects. So generally, the center of mass can be found by vector addition of the weighted position vectors which point to the center of mass of each object in a system. One quick technique in finding the center of mass separately for components along each axis. So we have here two axes. We have the X and Y axis. So we have here, for example, we have here center of mass X. This will, the formula that we are going to use along the X axis will be mass 1 multiplied by position plus mass 2 multiplied by position, again mass 3 multiplied by next, then etc. And it must be divided into their different masses. Okay, so that is the position or the center of mass. Next, we have also the center of mass along Y axis. So similar to the formula in finding the center of mass along x-axis. So m1 y1 plus m2 y2 plus m3 y3 and so on. It depends on how many objects with their center of mass is present in the illustration, divided by m1, m2 plus m3 and so on. So focus on this illustration or focus on these different formulas. Okay, so let's have example number 1. So example number 1. Supposedly this is the problem. In search of the center of mass. Solve the problem systematically And take note, completely. Find the center of mass of the object as shown below. So, for example, this one is the illustration. The first thing that you should do, guys, is to write for the given. So, it is already written in the diagram. So, let's assume this one is 1, this one is 2. So, we have here mass 1 is equal to 2 kilogram. Then we have here mass 2 is equivalent to, this one is 6 kilogram. Then we have x1, this one is 2 meter. Then x2, this one here, 8 meter. Unknown, our unknown is the center of mass. Since this one is vertical, horizontal, this will be m of x, unknown. Okay, so next formula, since we only have two objects in the illustration, we have cmx is equal to m1x1 plus m2x2 divided by m1 plus m2. Then for the solution, we have cmx is equal to, just substitute the values, m1 is 2 kilogram multiplied by x1 is 2 meter plus again 6 kilogram times 8 meter divided by 2 kilogram plus 6 kilogram. So this will be equivalent to 2 times 2, this will be 4 kilogram meter plus 6 kilogram times 8, 6 times 8, 48 kilogram meter divided by 2 kilogram plus 6, this will be 8 kilogram equals 4 plus 48, 52 kilogram meter divided by 8 kilogram. So cancel kilogram. cmx is equivalent to, so we have here 52 divided by 8, 6.5 meters. So meaning the center of mass is something like in this portion, 6.5 meter. Okay, so that is our example number 1. Next, let's have this one, example number 2. A system of 3 flat objects. Determine the center of mass in x and in y axis. So, for example, this one is the illustration. The very first thing that we should do is determine the given. So, let us solve first for x. But then, I want you to follow this instruction in solving your answers. Fold your paper into like this one, so that the first step or for your solutions, occupy first in this portion before going to that one, so that it will be synchronized. Okay, so let's have given. For example, x-axis muna tayo. Let's start with x-axis. So pag x-axis, pag ganun yung pabilang. So let's assume this one, this is 1, 2, and 3. Okay, so we have here 3 flat objects. So first is to write for the given. So mass 1, we have 1 kilogram. Then our mass 2 again, this one is 1 kilogram again. Then we have mass 3 is equivalent to 2 kilogram. Then next is determine the different positions, x1, x2, x3. So let's count for x1 since it is horizontal, so x tayo. So let's determine the position. So we have here count 1, 2, 3, 4. So eto siya, 4. Okay, so this will be 4 meter. Then x2 again, so let's have a red ball pen. X2, we have 1, 2, 3, 4, 5, 6. Okay, so 6 kasi eto siya at the center. So we have 6 meter. The next is this one at x3. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's put there 12 meter. So we are done with our given. Next, unknown. Since we start with x-axis, so center of mass along x-axis. Then formula, we have three objects. So we have cmx is equal to m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. Okay, then for our solution, just substitute the values. So m1 is 1 kilogram, so 1 kilogram times that one 4 meter plus again 1 kilogram times 6 meter plus 2 kilogram times 12 meter divided by 1 kilogram plus 1 kilogram plus 2 kilogram. So 1 times 4, this one is 4 kilogram meter plus 1 times 6, 6 kilogram meter plus 2 times 12 is 24 kilogram meter divided by 1 plus 1, 2 plus 2, 4 kilogram. So 4 plus 6, 10 plus 24, 34. So we have 34 kilogram meter divided by 4 kilogram. So cancel. CMX is equivalent to, we have 34 divided by 4. This will be 8.5 meter. So the center of X along x-axis is 8.5 meter. Next is for the y-axis. Okay, so again, we should write the given. But since we already know the mass 1, mass 1, mass 2, and mass 3, just copy that one. So 1 kilogram, 1 kilogram, 2 kilogram. We need to find y1, y2, and y3. So we need again to count in the illustration. Going y-axis naman tayo. So let's start with 1. So since this one is 0, start tayo doon. So let's count again. So count na naman natin. So let's have this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have here y1 is 12 meter. Next is y2. So eto y2. 1, 2, 3, 4, 5. So we have 5 meter. Next, in this portion, y3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 yan. So, something like in this portion. So, 8.5. So, we have 8.5 meter. Okay, so we are done with our givens. So, unknown is CMY. Then, for our formula, we have CMY equals M1Y plus M2Y2 plus M3. Y3 divided by M1 plus M2 plus M3. So that will be the formula that we are going to use. Then, for the solution, substitute again. So we have CMY. M1 is 1 kilogram times 12 meter plus 1 kilogram times 5 meter plus 2 kilogram times 8.5 meter divided by 1 kilogram plus 1 kilogram plus 2 kilogram. So, this is equivalent to 12 kilogram meter plus 1 times 5 kilogram meter plus 2 times 8.5. This will be 2 times 8.5, 17 kilogram meter divided by 1 plus 1, 2 plus 2, 4 kilogram. So, 12 plus 5, 17 plus 17. This will be 34 kilogram meter divided by 4 kilogram. So, cancel kilogram, kilogram. This will be equivalent to 8.5 meters. So, CMY is equivalent to 8.5 meters. So, center of mass X and center of YX is equivalent to 8.5 meter. Okay, as simple as that. So, next is you're going to answer what is presented or posted in your task in class E. Okay, so you can proceed now. I hope you learn well. Goodbye, grade 12 STEM.